Alright, this is the beginning of the video for going over the Trigonometry Test Review 1 worksheet as we get ready for the trigonometry test. The first section is vocabulary, and I'm just going to go ahead and put those answers in there for you so you can check your work. So let's go ahead and put this in. Adjacent leg is the leg that is next to the reference angle, that's C. And cosine is, if you think about it, if you think write down the test, Sohcahtoa, cosine is adjacent over hypotenuse, which is letter A. Hypotenuse is, we got two ways to think about this. It's the longest side, or it is the side that does not touch the right angle. So letter J, the side that does not touch the right angle. Inverse trigonometry, we use inverse trigonometry to find missing angle measures, or missing angles of a right triangle, so that would be H. The opposite leg is the leg that is across from the reference angle, and I see I have a typo here, so across from the reference angle, you can get rid of that part right there. Across from the reference angle, which is letter I. Let's see what we got here next. The reference angle is letter D, the right triangle angle used along with the trig function to find the ratio of two side lengths. So that would be letter D. Next one, sine Sohcahtoa. Sine is opposite over hypotenuse, which is letter E. Special triangle, well, we learned special triangles are triangles that we can find the lengths of the sides without using trigonometry. That's letter F. And then tangent, Sohcahtoa, toa, opposite over adjacent, which is letter G. And the last one, trigonometry. What is trigonometry? It is used to find missing side lengths of a right triangle, which is letter B. So there's our vocab. Alright, questions 11 through 13 have us practicing special triangles, 45, 45, 90 triangles. I'm going to go through these step by step using the procedure that I taught you in class. When you recognize it's a 45, 45, 90 triangle, first thing you do is you're going to label your sides with what you know about 45, 45, 90 triangles. If the legs are x, then the hypotenuse is x times the square root of 2. Next step is you're going to circle the side that you are given, and that's going to become an equation. So what we're going to do is we're going to set x equal to 35, and we're done because the goal of special triangles is to find the value of x. So we already know that x is 35. Well, if x is 35, actually 35 feet, then we know that PR is equal to x. So that means PR is equal to 35 feet. And then PQ, we know that is the hypotenuse. PQ is going to be x times the square root of 2. Well, x is equal to 35, so x times the square root of 2 is equal to 35 times the square root of 2. Let's go ahead and put that in our calculator. 35 times the square root of 2, close parentheses, equals, we've got 49.49 or 49.5. So it's approximately 49.5, and that's also in feet. Now this particular question does not say label the sides of the triangle, but I'm going to do that anyway. So the hypotenuse is 49.5 feet, and the other leg is 35 feet. And the reason I do that is, hey, it makes sense. The hypotenuse is longer than the two legs, so that at least makes logical sense. Question number 12. This is a 45, 45, 90 triangle. We're going to label the legs. and the hypotenuse is x times the square root of 2. We are given the hypotenuse, so I'm going to circle that. And that means we know that x times the square root of 2 is equal to 14. And now we're going to divide both sides by the square root of 2 because we want to get x by itself. That's our goal. The square root of 2 over square root of 2 now cancels. And we have x is equal to 14 divided by the square root of 2. And that makes the rest of our work pretty easy. The leg ST is equal to x, and we already know that x equals 14 divided by the square root of 2. Let's get our approximate value for that. So 14 divided by the square root of 2 is approximately 9.89, so 9.9. Our unit of measure is meters. And then UT, well, UT is also a leg of a 45-45-90, so that's going to be the same thing. UT is going to be x. Oops, let me change that color. Since UT is a leg, it's also x, and x is equal to, still equal to 14 times the square root of 2, so this leg is also 9.9 meters approximately, and I'm going to go ahead and label that. So UT 9.9 meters, and ST is approximately 9.9 meters, and that makes sense. The hypotenuse is 14. It's the longest side. It's greater than 9.9, so that makes sense. All right, let's go ahead and take a look at number 13. Same procedure. It's a 45-90, so 45-45-90 triangle. The hypotenuse is on this side now, across from the right angle. So that's going to be x times the square root of 2. And this leg is x, and this leg is x. I see they have given me the length of one of the legs. So that means we can set that as an equation. X equals 26.7 centimeters. So side DE is also a leg that's going to be equal to x. And we just found out that x equals 26.7 centimeters. I'm going to go ahead and label that now. And now all we have to do is find the hypotenuse, which is DF. DF is going to be x times the square root of 2. All we do is plug in our x value, 26.7 times the square root of 2. And that's going to be approximately, let's see, 26.7 times the square root of 2. And that's equal to 37.75 or 37.8 if we round to one decimal. So approximately 37.8 centimeters. And let's go ahead and label that here, 37.8 centimeters. That makes sense. The hypotenuse is longer than the legs. So far, so good. And that's how we're dealing with special triangles. Let's do the next three in the same video here. Question number 14. Now we're looking at a little more complicated situation, but not much. These are 30, 60, 90 triangles. It's asking us to find the missing measures using the rules of special triangles. Well, we remember classes, when we look at a 30, 60, 90, the side that's touching, the leg that's touching the 60-degree angle is the short leg. The leg that's across from the 60-degree angle is the long leg. And AB, which doesn't touch the right angle, that is the hypotenuse. So short leg is going to be x. Hypotenuse is 2x. Long leg is x times the square root of 3. Alright, let's go ahead and circle the side they gave us, which happens to be the short leg. And that means we know that x is equal to, let me fix that, x is equal to 18 centimeters. Well, that's the hardest part. We're done. We know what x is, so they want us to tell them what AC is. Well, AC is the long leg, x times the square root of 3. I'm going to change that color. So the long leg is x times the square root of 3. So if it's x times the square root of 3, and we know that x is 18, then all we got to do is plug 18 in there for x, and 18 times the square root of 3 is equal to 31.17. We can round that to 31.2, approximately 31.2 centimeters. And then we've got AB. AB is the hypotenuse. That's going to be 2x. So 2x is equal to 2 times x, which is 18. And that's going to be 36 centimeters. Let's label the hypotenuse. 36 centimeters. Let's go ahead and label the long leg. 31.2 centimeters. Let's see if this makes sense. Hypotenuse is the longest side. Long leg is longer than the short leg. It all looks good. Let's continue with the next one. Every time, class, same procedure. Alright, we've got a 30, 60, 90 triangle. The side that is opposite or across from the right angle is the hypotenuse. That's going to be 2x. The side that is adjacent to the 60-degree angle, which is right here, that's going to be the short leg, which is x. And then the long leg is going to be ED, which is x times the square root of 3. Looks like they have chosen to give us the hypotenuse. That means we know that 2x equals 17. Divide both sides by 2, and x equals 8.5 inches. We've reached our goal already. We know what x is. ED is the long leg. That's going to be x times the square root of 3. And that's going to be equal to 8.5 times the square root of 3. And I'm just going to go ahead and give you that answer. That's approximately 31.2. Oops, sorry, got that one wrong. 8.5 times the square root of 3 is approximately 14.7, and we're looking at inches. And then EF is the short leg, and that is just equal to x. So x is equal to 8.5 inches. So let's label our short leg 8.5 inches. We'll label our long leg 14.7 inches. Hypotenuse is the longest side. Long leg is longer than the short leg. It all looks good. Hey class, on these, just be careful when you label the sides of a 30, 60, 90. Make sure you're properly identifying what is the long leg and what is the short leg. The hypotenuse should be easy. Last one is number 16. Again, 30, 60, 90 triangle. We've got our hypotenuse here, RT, which is going to be 2x. The side that is adjacent to the 60-degree angle is our short leg, and our long leg is on the bottom here, RS, which is x times the square root of 3. This is probably the most difficult problem of special triangles when they give us the long leg of a 30, 60, 90. It's not that bad though. We know therefore that x times the square root of 3 equals 24. We're going to divide both sides by the square root of 3. That's going to cancel the square root of 3 on the left side. We've got x is equal to 24 divided by the square root of 3. Alright, RT is the hypotenuse. That's 2x. That means RT is 2 times 24 divided by the square root of 3. Let's go ahead and put that in our calculator. Two ways to do that. You can do it all at one time. I'm going to do it all at one time. Or you can do 24 divided by square root of 3 and then multiply it times 2. I'm going to do it all together. So 2 and then parentheses 24 divided by the square root of 3. Make sure you close both sets of parentheses here. We've got approximately 27.7. So 27.7 meters. And then we've got ST, that's our short leg. Well, that's just going to be x, which is 24 divided by the square root of 3. And let's put that in our calculator. We're going to end up with approximately 13.9 inches. Whoa. Sorry for that sound. Goodness gracious. Stop, stop, stop. Well, I couldn't have got that any louder. Sorry about that, class. That meant my 15 minutes was up. Let's wrap this up. So, ST was 13.9. Man, that scared me. So I hope it didn't scare you guys too much. 13.9 inches. And our hypotenuse was 27.7 inches. Hypotenuse is the longest side. Long leg is longer than the short leg. That all looks good. So this again goes through the process of how to find missing side lengths of special triangles. Hopefully you are practicing these steps and finding they're not that difficult to do. Just follow the procedure.